Welcome to our final video over nomenclature. Today we will learn acid nomenclature. Please take meaningful notes and have your periodic table handy. There are two ways acids are named depending on their construct. First, we have binary acids, which consists of a hydrogen ion and an anion that does not contain oxygen. Some examples are HCl for hydrochloric acid and H2S for hydrosulfuric acid. Then we have oxo acids, and they have a hydrogen ion bound to a polyatomic anion, which contains oxygen. Oxo acids will often be ternary. Some examples are H2SO4 for sulfuric acid, HClO for. Now, how do we name those acids? First, let's look at how we name a binary acid. Binary acids always start with the word hydro. Then we have to determine the root of the anion, and we follow that by ic and then add the word acid. Let's do some examples to illustrate that. First example is HCl. So we said that binary acid always start with the word hydro, so I write hydro. Then I check my anion, it is Cl. Cl is chloride, and I change that ending to ic, so it becomes chloric. And finally, I write the word acid. You have to write the word acid for the name to be complete. In our second example, we have HF. So again, it is a binary acid. So the first thing I do is write hydro. Then I check my anion. It is F. F is fluoride. And I have to change that ending to ic. So fluoride becomes fluoric. And finally, I write the word acid. Now let's name oxo acids. Oxo acids, remember, are the hydrogen ion bound to a polyatomic ion containing oxygen. We have to look at our polyatomic ion to decide how to name it correctly. So let's do some examples. HNO3. We have NO3 as our polyatomic ion bound to hydrogen. NO3 is nitrate, and nitrate ends with 8. When your polyatomic anion ends with 8, you have to change the ending to ic. Oxo acids do not have the word hydro in their name, so nitrate becomes nitric. And again, I have to write the word acid to finish the name. A useful saying to remember that polyatomic ions ending in 8 will change their ending to ic is I ate something icky. Let's do the second example. We have H2CO3. So I look at my polyatomic ion again. It is carbonate. Again, I have the 8 ending, so that needs to change to ic. Carbonate becomes carbonic. And I have to write the word acid. Now we're going to look at the oxo acids where the polyatomic ion ends in ite instead of 8. Exactly the same rules apply, except the ending will be a little different. This time we are going to change the end of our polyatomic ion from ite to OUS. Let's do a couple of examples. So if we have HNO2, I look at my polyatomic ion attached to hydrogen. NO2 is nitrite. My ending is ITE, so I need to change that to OUS. It is an oxo acid, so no hydro in the name. So nitrite becomes nitrous. And again, I have to write the word acid to have the correct name. Our second example is HClO2. So I look at my polyatomic ion, it is ClO2. ClO2 is chlorite. Again, I see that ite ending. So I have to change that ending to OUS. So chlorite becomes chlorus. And I have to write acid. The useful saying for this one to remember is the snake bite was poisonous. A special note about sulfur and phosphorus. As you know from before, the ions for sulfur and phosphorus are sulfide and phosphide. Unfortunately, when the anion of an acid contains sulfur and phosphorus, the roots are sulfur and phosphor respectively, not sulf and phosp. So when we name H2SO4, it is sulfuric acid, not sulfate. H2S will be hydrosulfuric acid, not hydrosulfic. And then for phosphorus, H3PO4 is phosphoric acid, not phosphic. And H3P will be hydrophosphoric acid and not hydrophosphic acid. Unfortunately, sometimes life is not fair. Now let's go the other way, and we are going to write the formulas for acids given the name. Acids consist of a hydrogen ion which is bound to the anion. So we have to determine the anion in order to figure out what is bound to the hydrogen ion. And then we balance the charges with subscripts just like we did for ionic compounds. Please take note, acids are still classified as covalent compounds, even that we balance the charges to write their formula, just like for ionic compounds. So let's do some examples. Hydrobromic acid. I see the word hydro, so I know that my anion had to be a bromide because it had to be an ide ending anion. All acids begin with the hydrogen ion, so H+. Then my anion is bromide, so that is Br with a charge of -1. I balance the charges. They are both 1, so they balance out. So my formula is HBr. Hydrosulfuric acid, again, I see the word hydro, which tells me that my anion has to end in ide. That would be sulfide. So again, acids all begin with the hydrogen ion. Then my anion is sulfur with a charge of -2. This time the charges do not balance. So in order for them to balance, I have to multiply the hydrogen side by 2 so that I have a +2 and a -2 to balance out. So for each 2 hydrogens, I have 1 sulfur, and there is my final formula. Acetic acid. I see that my acid ends in ic and that I do not have hydro, so it must be an oxo acid. And then when I see the ending ic, I know that my polyatomic ion had to have an 8 ending. So the anion had to be acetate, which is C2H3O2 with a charge of -1. Again, all acids start with the hydrogen ion, so H+. Acetate is C2H3O2 with a -1. The charges balance, so it's a 1-to-1 ratio, and we have HC2H3O2. Finally, phosphorus acid. Again, I do not see hydro in, so it must be an oxo acid. So I'm going to go look for a polyatomic ion. I see that the ending is OUS. So I know that my polyatomic ion has to end with ite, so it will be phosphite. All acids start with a hydrogen ion, so H+. Phosphite is PO3 with a charge of -3. I balance the charges. I have a -3 on the phosphide side, so I have to multiply this side by 3 to get a +3 to balance out. So for my final formula, I need 3 hydrogens for every phosphide. This concludes our unit over nomenclature. I hope you have taken good notes. Come to class prepared with your questions.